Hey, it's Dan. I'm glad you came here to get some math help. Let me ask you to do something before we watch the video. Please subscribe and like this video. Let's do the math.
All right, so let's graph this quadratic. So we have g of x equals this. Now in this problem, the first thing you want to do is analyze what a, b, and c are. This is a, -3, b is -12, and c is -11. So we're going to find the vertex, and the vertex is found by using this formula, -b over 2a. So the opposite of b is 12. 2 times a is 2 times -3 because that's a. You do the math here, you get this, and then reduce, you get that. So the vertex, the x value on the vertex is -2. So the x value on the vertex is -2. Now we don't know this yet, but what you do is plug this in back into the original and solve for that. So let me do that over here. So if I put -2 into the original problem, and I work it down, -2 squared is 4, multiply there, this is -12, that's 24 minus 11. 12 minus 11 is 1. So that's where this vertex came from. So -2, 1 is the vertex. Also, it opens downward because this a value is negative. If the a value is positive, it opens upward, but if it's negative, it opens downward. And since a is -3, this opens downward. Now we're going to draw the graph for this, and in order to do that, what you want to do is go ahead and plot your vertex at -2, 1. So over 2, up 1, and put a dot there. And then draw a vertical dotted line like I've done here and call that the axis of symmetry. I'm calling it AOS, axis of symmetry, and I'm pointing to it, and I'm saying that's the line x equals -2. So the axis of symmetry is not a quantity, so we don't say it's -2. That would be wrong. We say it's x equals -2. So it's x equals a number, and that number is always going to be the x value on your vertex. So that is your axis of symmetry. What that means is this graph is symmetrical about that. If we were to cut this and fold it, the two halves would match up. Now, I went ahead and drew the graph, but initially I just had the vertex, and I did this table to get this point and that point, and then I drew the graph from that. So I chose 0 because it's not very far from -2. It's just over here. And then I chose -4 because it's exactly 2 spaces from there. So 2 spaces from -2 is -4, and 2 spaces from -2 is 0. One's to the right, one's to the left. I put these numbers 0 into the original problem, and I put -4 into the original problem, and I calculated for y. So in case you don't know what I'm talking about there. So I literally put 0 there and put 0 there and did the math, and that's where the -11 comes from on this. So 0, -11. And then you take 4, put 4 there and put 4 there and do the math, and you will find out that you get -11 there as well. So 0, -11 is down here. -4, -11 is down here. You draw the curve there, and that's what your quadratic looks like. So that's how you graph a quadratic when it's in standard form. That's what this is in. This is called standard form. Ax squared plus bx plus c equals the function. That's standard form for quadratic, and that's how you do it. So you find the vertex first, draw your axis of symmetry, determine which way it's opening, do a little table, and then use your symmetry to draw the graph.